Welcome. In the last video, I talked about the size that each of these data types occupy in memory. In this video, I'm going to show you how we can modify slightly how these data types are stored inside memory so that we may have some control as to what we can save. So let's get started. So Booleans are quite simple. There's a true and a false. We only need 1 byte to represent that much information. All right, nothing to talk about there. A character, we use a char data type to store it, and we use the ASCII standard in order to represent a particular character with a numerical value. So again, there's 128 characters in the ASCII standard. There's nothing to talk about there either. However, I did also mention that char can be used to store integers, and particularly when these integers are quite small. And of course, we can also store integers when we use the data type int. However, there's some things that happen that we have control of with these two data types when we use them as integers. So let's talk about those. So to talk about it, I'm going to use the data type char. So I said that char could represent as high as the number 127. So let me write this here, 127, which I said is 7 ones. And because we have to represent every piece of information as a byte, then I have to also put a 0. Now, one thing that came up in the last video is how come we don't use this bit? Surely I could go higher than 127 if I was to use this bit, and I could represent more characters. And there's a reason why we don't use this 0. Notice that in all of these videos, I have only talked about positive integers. But what happens when we try to use a negative integer? So the number 0 has a representation of 8 zeros, right? Nothing crazy. What about the value -1? Well, the value 1 is 7 zeros and then a 1, right? However, there's an issue. We don't have a negative symbol inside of the computer. Remember when we had to split integers and floating numbers because there was no such thing as a period? Well, we have the same problem here. We do not have the concept of a negative sign. So what do? Do we just make a whole new data type for negative numbers? Well, we certainly could do that, but that could be quite tedious to deal with, and since we already have two numeric data types to worry about. So what was decided instead was that why don't we use the very first bit, or I should say the last bit, as the sign of the number. So if the number is negative, I will represent that with a 1. And if it's positive, I will represent that with a 0. Therefore, -1 would be represented how? Well, the first bit would be a 1, because again, we're negative. And then we'll have what? 6 zeros. That's 6 zeros, and then the 1, right? So this would indicate a -1. How would a positive 1 look? Well, it would be the same thing, except that the very last bit, right here, this would be, well, that's a weird arrow. This would be a 0, and this will be a number 1. The very last bit, or the first bit from left to right, is used to indicate the sign of the integer. Now, what if the numbers that you're dealing with are all positive? You're dealing with some piece of software, and you're saying, I don't have negative integers. It seems pointless to me to waste an entire bit trying to represent negative numbers, which I will never use. Therefore, there is a way for you to tell the computer or to tell the C++ compiler, hey, I want you to treat this char data type in such a way that we do not need to represent negative numbers. In other words, I don't want you to do this little scheme that we have on the left. To do that, we use a thing called data type modifier. There are two data type modifiers that we have in order to control this option. We either say that the data type is signed or unsigned. So what I'm saying when I say sign, I am telling the compiler, hey, I want you to use that mechanism where the 8th bit is used to represent whether it's a negative or a positive. However, if I say I want it to be unsigned, then what I want you to do is not use this mechanism and instead use the 8th bit to represent more integers. What does this mean? Well, for sign, everything is the same. We have done that. We already did it, right? We can represent at most the number 127, and that's it. when we do unsigned, we have an extra bit to represent positive numbers, which means that in here, the maximum number that we can go to is 255. So if you wanted to represent the number 200, now you don't have to go to an int data type. You could do this with a char by simply saying that I want this char to be unsigned. Now let's go take a look at how this looks in code. So here we are where we left off last time. So let's make some space, and I'm going to go with char result is equal to 0, right? And we're going to run this, and let's see how this looks. So here we have result is 0, right? So what we want to do is we say that the highest number we can represent with char is 127. And if we run this, you know, here's 127. And if I wanted to go to, let's say, 200, I couldn't do that. So instead, what I could do is I can say, well, I want this char to be unsigned, right? Unsigned char. So now, and if I run this, you notice that nothing gets changed. It's still result 127 because, again, this is not affected by it. But now I should be able to put, let's say, the number 200, and I run this. And here we go. Result is 200. Now, because I don't want you to think that I'm lying to you, let's remove this unsigned and let's just see what happens. Okay? Result is negative 56. But we put 200. Okay? That's an error. And why exactly we got negative 56 here? That's something that I'm going to talk about on the next video. However, notice that when we put unsigned, we're now able to put 200 because, again, we get that 8th bit, which let us double the amount of positive numbers that we can represent. So instead of 127 being the maximum, now it's 255, okay? By default, in Visual Studio, this could be different from compiler to compiler, but in Visual Studio, by default, char, and same thing with int, so int, let's just say result 250, let's just change the number. By default, these two are going to be signed, which means we can represent a negative number, 250. And I can run this, and let's just type result 2, and that should be what? Result negative 250, right? So by default, they are signed. So if I type signed here, and I run this, it makes no difference. So there's no need for us to use signed unless you wanted to specifically say, hey, this is a signed integer. Again, Visual Studio, by default, they are signed, so we don't need that. So data types that can represent integers like char and int are able to represent both positive and negative integers by using the last bit or the first bit from left to right as a signed bit, meaning that if this bit is a 1, then it is a negative number, and if it is a 0, then it is a positive number. However, thanks to these data type modifiers, sign and unsigned, we are able to specifically dictate whether this integer data type should be handling only positive or negative integers. By disabling the ability to represent a negative integer, we're able to double the range of positive integers that we can represent thanks to that extra bit. So we use the unsigned keyword to tell the compiler that the data type should be an integer data type that doesn't have to take into account negative numbers. And by default, if we do not tell the compiler whether the integer is a unsigned or signed, by default it's going to be using a signed integer in Visual Studio. However, have in mind that this could vary from compiler to compiler. We will continue and talk about other data type modifiers in the next video. If you found this video useful and you don't mind, leave a like. If you have a question, feel free to leave a comment in the comment section below. If you're new to this channel, check out the video series. Check out the channel if you like what you see. Subscribe, be safe, and peace out.